In a previous project, I found a free TV and turned it into a giant solar scorcher. This shoots out a deadly beam of sunlight that's hot enough to abuse food, melt metal, and burn things you probably shouldn't.
Let's say this beaker full of very warm water is a source of heat. Here's a special type of engine, a Stirling engine named after the Stirling brothers who invented it, got a patent in 1807. The heat from this water is warming the bottom plate of this engine. Give it a little nudge. The engine will run. Now notice there are two pistons. There's this little one up here, the primary, and then there's this big one down here, the secondary. And as the heat from this water warms the bottom plate, it makes the air expand. The expanding air drives the piston. So this is a way to convert the energy of heat into what we call mechanical work, or making something spin. And the extraordinary thing about Stirling engines is they're so efficient. It's just a little bit of hot water, and look how fast it's making the wheel go. Now watch what happens when we take the same Stirling engine running clockwise and put it on another beaker, but this one's full of ice water. In just a few seconds, the Stirling engine will slow down because it's lost its source of heat from the bottom. But now it will run the other way from the ice. So there's an old joke in science. A thermos bottle keeps cold things cold and hot things hot. How does it know? Well, the reason it knows is because, in a sense, in science, there's no such thing as cold. There's only the absence of heat. So this is still a heat engine, and it's running off of heat. But the source of heat now is the room. The air in this room is warming the top plate, and heat is now flowing down through the engine instead of up through the engine as it was over on the source of hot water. Now, Stirling engines have been proposed for all sorts of things. In the early 1800s, they were used to pump water all over the place. People have talked about putting them in cars again. But the tricky thing about a Stirling engine, they're hard to speed up and slow down. The great thing about a car engine is you can speed up and slow down very easily. You've probably heard of a diesel engine. That's named after a guy named Diesel who invented the process. Then your car that runs off gasoline has the Otto engine, O-T-T-O, another German scientist. There's all sorts of heat engines. There's the Watt engine, the Rankine engine, the Brayton engine, the Atkinson engine. And they're all different arrangements of pistons and valves to convert heat into mechanical work. It could be that the Stirling engine's going to make a big comeback because it's so efficient. And maybe you'll be the scientist or engineer who finds a way to use it in extremely important applications. You could, dare I say it, change the world.
In a previous project, I found a free TV and turned it into a giant solar scorcher. This shoots out a deadly beam of sunlight that's hot enough to abuse food, melt metal, and burn things you probably shouldn't. Today seemed like a good day to play with my solar scorcher. I positioned my frame and found the focal point, then added some concrete tiles as a base for my projects. Okay, I've got power, and I'll test it out with this piece of wood, and when the light makes contact, I've got instant fire. The sunlight at this spot is around 2,000 degrees Fahrenheit, enough to melt this spot of concrete into a glowing orange liquid. I'm curious to see what I can do with all this heat, so I filled a glass bottle with water, and I'll punch a hole in the cap. It's incredible to see that the instant I focus my lens on the bottle, it starts smoking. Just a few moments later, this water is so hot it's boiling, and I'm a little nervous the bottle might blow. Yep, there it goes. The glass pieces are melting and that's cool, but now I want to try this on some food. I'll get some hot dogs, and when they hit the beam, they really do get hot. This might be a little well done for my taste, and I'm still hungry, so let's try an egg. The egg is actually working very well. It's so reflective it doesn't burn as fast, and even my wife is interested. A little salt and pepper, and it's tempting to try a bite. Okay, so I wasn't actually expecting to eat this, but it looks safe enough, and even my kids are anxious to try. Surprisingly, it's pretty good. Alright, let's see what else this will do. I'll try burning a penny, and wow, it melted. How about a stack of pennies? Yep, they're nothing but liquid metal now, and I'm thinking that slag in the mixture must be what's left of the copper coating. It's only taking about 4 seconds to melt these, and melting metal is really great, but now I want to see something burst. I wonder what would happen to this egg. It's spewing some kind of debris and smoking like crazy. I hear some little pops, and it's even forming some interesting growths. Oh, look at that. But no explosion. How about if I put a pop top on this bottle of water and let the pressure build up? Yeah, that's what I'm looking for. Let's do that again. The lid is back on and pressure is building. Awesome. Alright, the sun is setting and I've readjusted my A-frame. I'm just wondering if this would ignite gasoline. It does. Hopefully it goes without saying that this is very dangerous and you shouldn't try this at home. Well, I'm convinced there's an insane amount of power behind these lenses. If you'd like to see where I got this one, take a look at my video on how I hacked it out of an old TV. This one boiled water in less than a minute, welded a nickel to concrete, and instantly torched any piece of wood in its way. Well, that was fun, but I'm still hungry, so I'll put
AOE 2020. Never be you. I will never be you.